Okay, so let's practice some problems from 7.1. We're in the chapter review found on page 578. We're under section 7.1. As you see on the screen, I've selected 5 problems for us to practice together. Problems 1 and 2, my instructions are, one second, let me get my pen. Instructions say, find all numbers for which each rational expression is undefined. Find all numbers, basically find all x's, for which the rational expression is undefined. So what does it mean to be undefined? Undefined means you are dividing, mind my scribble, by 0. We cannot divide by 0, therefore if you end up with a 0 on the bottom, it's undefined. Alright, so let's see here. What's the first thing you got to do? When you're trying to find values for which your rational expression is undefined, you set your denominator equal to 0. So 6x minus 24 equals 0. And then we're going to solve for x. Add 24 on both sides. We end up with 6x equals 24. Divide by 6, divide by 6. And I have x equals 4. And of course you can check your work. Plug 4 back in. And you do in fact get 0 in your denominator. Therefore, when x is equal to 4, this rational expression is not defined. Alright, what about number 3? We're going to do the same thing. We want to find all find all numbers so that the rational expression is undefined. You do the same thing. You start off by setting your denominator equal to 0. And then you must solve for x. Now this is a trinomial, so I can't solve for it like I did in number 1. I have to factor it. So let's see here. How about we factor it using products and sums? Now I'm not going to break this down because we already did that before. If you need extra help on factoring, there's a video on factoring. So I'm going to go ahead and factor this. This is x minus 2 and x minus 1 equals 0. Now of course let me check myself. Negative 2 times negative 1 is 2. Positive 2. That works. Negative 2 plus negative 1 is negative 3. That works. Good. So I end up with x minus 2 times x minus 1. And the rule is if you have the product, if the product gives you 0, you set both things equal to 0. So that means x minus 2 equals 0 as well as x minus 1 equals 0. Because remember, how would you get 0? Either this first piece is 0, and 0 times anything is 0, or the second piece is 0, and 0 times anything is 0. Great. So that comes out to be x equals 2, x equals 1. And that's your final answer. If you plug 2 back into the original rational expression, you'll get 0 in your denominator. Let's check that real quick. I got it. Good. If you plug 1 in, you get 0. Great. So those are problems 1 and 3. Problem 7, 9, and 11. The instructions are simplify each rational expression. All you gotta do is simplify it. Okay? So when we simplify, the first step is to factor the numerator and denominator. Factor both. And again, I'm going to factor it with very little discussion on how to factor. If you need help on factoring, make sure you're watching the video on factoring. So the top factors into x squared, and I have x plus 2. The bottom factors into x plus 2. I can't factor the bottom. Good. So factor the numerator and the denominator, and then the second step is to simplify. Let's change colors here. Let's go for a blue. Well, x plus 2 divided by x plus 2, they cancel out, and I'm left with just x squared. Therefore, this rational expression, x to the third plus 2x squared, all divided by x plus 2, is the same as saying x squared. If you were to graph this using a graphing calculator, the first one, if you graph this rational expression, you will get the parabola x squared. Awesome. Let's move on to number 11. So for number 11, I also want you to simplify. Simplify. How do you simplify? The first thing you got to do is factor the numerator and denominator. You must factor. Alright, so let's see. Does the top factor? It does. It's x minus 5 times x plus 1. Divide by, does the bottom factor? X plus 7 times x plus 1. Good. And of course you can check yourself. 7 times 1, that's positive 7. 7 plus 1 is 8. If you remember products and sum, it's very simple to check yourself. Negative 5 times positive 1 is negative 5. Negative 5 plus positive 1 is negative 4. Good. And then the second step is to simplify. Simplify. So let's change my color again. And let's simplify this. Well, x plus 1 cancels out with x plus 1. And my final answer is x minus 5 divided by x plus 7. Great. So far, so good. So let's move on down to number 11. I have to simplify this, just like I've been doing. And it says x squared divided by x squared plus 4. Well, in order to simplify it, I need to first do what? Factor the numerator and the denominator. You need to factor them, right? Now, the numerator is a single term, so it's just going to be x squared. He's just a single term. The denominator is x squared plus 4. Is it factorable? Can I factor it? The answer is no, you cannot. And why is that? Why can I not factor x squared plus 4? So why can we not factor x squared plus 4? Why? It's the plus sign. It is not the difference of two squares. It is the sum of two squares. Therefore, it's not factorable. I cannot factor this because of the plus sign. So it's not factorable, if that is even a word. Which means that this thing right here isn't factorable. Therefore, it's simplified. It cannot be simplified anymore. It's in simplest terms. So it's in simplest. Let's see if I can spell that. How do you spell simplest? Give me a second. How about we say simplified already? Simplified already. So you have no more work to do to this one. Okay. Let me know if you have questions. Practice the factoring. Once you get the factoring, everything else is very straightforward, but you really need to make sure you can factor.